Hey everyone. I want to talk a bit about the distillation process now. So we've gone through, started with our grain in one video. That comes through to a sugary liquid called wort. Yeast is added to that. Then you get a distiller's beer coming out of that, which is now an alcoholic liquid, full of all kinds of flavor, at about 10 to 15%. The next phase is distillation, and this is where we want to increase the alcohol in the beer up to a fairly high percentage. So often around 70%, higher or lower depending on what we're making. And this is done through distillation. And the other role that distillation has is actually concentrating and selecting what flavors we want in our whiskey. So there's two main types of stills that are used in Canada for distillation. You have column stills and then you have pot stills. And a lot of distilleries will have both, and they'll use both. And so, if we zoom back, we're using multiple types of grains, multiple types of yeast and fermentation types, and multiple stills at the same distillery. So tons and tons of products we're making. So column stills are quite efficient stills, and they're, I like to call them industrial. I mean, really all of this you could say is an industrial process, but the reason I say that is just because they're efficient and they can process, so much beer. And so this is how it's done, and this is how it's done if you're making ethanol for fuel or whatever. You'd use a column still. So how column stills work, what we're trying to do is basically strip alcohol out of our beer. And as we do that, we have tons and tons of organic compounds that are going to go with the alcohol. And these are the flavors that we're collecting and will end up in our whiskey. And so the kind of, I guess, science behind distillation is that water, as we know it, boils at 100 degrees Celsius. Ethanol alcohol boils at 78 degrees. So as you heat up a beer, as you start to approach 78 degrees, you get some evaporation of water, but alcohol at that point is ready to boil. And so as you heat up to 78 degrees, you start to get increasingly more alcohol evaporating compared to water. And so this like alcoholic steam basically we want to capture, and then we can condense it back to liquid. And at that point we have, we've taken out more alcohol than water, and so we've increased the concentration of alcohol. So that's what distillation does in a nutshell. You're heating up your beer so that the alcohol starts to boil off, and because it starts to boil off before the water, we don't have to take it to 100 degrees, before we start to get a lot of alcohol coming out and it's concentrated. So, kind of by this process, you could think about it, if you were just heating something in a pot still, which is just sort of a kettle, at the start you start to get more and more, like a higher percentage of alcohol come off the still, because you slowly start to heat up the liquid in the still, and then it slowly starts to drop, because as the temperature keeps rising, you get, there's still more alcohol, but you're approaching now, the boiling point of water, so you have more water coming as well. So what a column still does is you pump your beer to the top of a column still, and the beer starts to fall down a series of plates. And column stills are also advantageous because you can actually pump in the grist with your beer. So you can have kind of chunks of the grain that are still left over from the milling process, from grinding your grain. And that can actually go all the way through and be processed in a still. And so as the beer comes down, it starts to fall down a series of plates from the top all the way to the bottom. And what you have at the bottom of the still is you have heat, which is creating steam, which is rising up the still. And so as the beer is falling down the still, you have a heat current that's coming up, and as it heats up the beer at each plate, you have alcohol starting to evaporate off and boil off, and so the beer comes down the still, and as it comes down the still, the alcohol slowly gets stripped out of it and rises up the still and off the top. So that's how column stills work. They're really advantageous, and they're often, you can call them continuous stills as well, because you can keep pumping beer in the top, and you'll keep getting alcohol out the top of the still. So you have beer coming in, and then you have your beer, what's left over from your beer, coming out the bottom, but it's been stripped of the alcohol. Really nice. You can get really high percentages of alcohol coming out of a column still, like 60%. In Canada, if we're wanting a really, really light spirit, we can distill through that column still twice, or distill through another one, and get alcohol in that the 90 to 95% range coming off that still. So that's column distilled whiskey. It's interesting to taste it, because it tastes different than pot distilled whiskey, which is what I'll talk about next. So I'll come back to that. So pot distillation, what you have is basically a kettle. So you have a kettle, and you put your beer into it. So you kind of had a kettle, you put your beer in, you close the lid, and then you start to heat up your beer from the bottom of your pot still. And as the beer heats up, the vapors start to evaporate, and you get the alcohol start to come off and then up the still. And the way pot stills are designed, you have sort of a you have a kettle here, so you have your beer in there, and then you have a long sort of neck. This is a little whiskey mini, by the way, but it is a still, and you have a long neck at the top. And as you progressively get away from the heat source, you have cooler and cooler temperatures, and so you start to get the vapor condensing against the sides of the still, and then it would just run back down. And so you have this kind of continual process of evaporating off the beer, going up on the side of the still, and then falling down. But at the top of the still, there'll be some arm that'll go down, called the line arm. And basically when vapor gets to that point, it'll come down off the still, and then it'll get condensed outside the still, and that's your final spirit that's collected. So it's just another form. It's fundamentally different than in how it sort of does its distillation from a column still, because it's a batch process. So you have a set volume of whiskey of beer in the bottom of your still, and you're slowly heating it up. And as you're heating it up, different flavors are coming off, basically, because as you start to heat it up, you basically have all your compounds in there with really low boiling temperatures, some of them in the 20 degrees, 30 degrees, start to evaporate off first. And then, as you continue to grow, all these other flavor compounds start to evaporate off that are heavier. And you have alcohol evaporate off as well. And there's kind of a mixing, right? So you have some compounds in the 20 degrees that might not evaporate until the liquid's 30 or 40 degrees, because everything because it's a solution, it doesn't all come off at exactly the same time. If you distill slower, it'll come off, there's more time for it to kind of find its way, so to speak, up through the still, and you'll get a bit more of a linear process. But if you distill faster, you get kind of more of a blurring of flavors. What makes this style of distillation really interesting is you see flavor development as the temperature in the pot still increases. So, as you start distilling, you get a bunch of flavors which really aren't desirable, and in a pot still you don't want to keep them, and you just don't keep them, and those are called heads. And these really like high alcohols, really kind of intense chemical aromas that are really sharp, you don't want to keep them. And then you start to get all these other flavors develop kind of over time as the distillation run continues, and you start, you get some fruity flavors, and you get some floral flavors later, and some more like grainy, earthy flavors, later in the distillation run. And so it's kind of a fun thing for a distiller, because you can really pick and choose like what flavors we want to keep and which we want to throw away. You can still do that in a column still, but it's less it's more about tuning the whole still than just kind of picking your time. So that's pot still distillation. Now there's other videos that explain that. It's a bit hard to do that without graphics. There's some other areas to look if you're curious to learn more. But what I do want to talk about is the flavor character you get from the different stills, and this is really why it's even worth, I think, talking about the different types of stills, unless you just are curious about the science. Column stills give you a flavor characteristic, so that are different than pot stills. And so when you've gone through a column still once, say to about 60% alcohol, you get this whiskey or this spirit, I suppose, that has this really, really broad set of characteristics. So bourbons are column distilled, not by law, but the big distilleries use column distilled. So the bourbons that are well known are column distilled or easy to access. And if you taste them, they're these really, it's this really broad base of flavors, like all this stuff's happening, and it's actually pretty, it's often kind of raw coming off the still, which is why column distilled whiskeys often use new oak, which more aggressively tames the spirit than oak that's been reused in their barrels. And so if you're distilling corn once through a column still, you get something that would be reminiscent to a degree of a bourbon before it's matured. And even if you matured a new oak as you would a bourbon, you get something similar in character to it. If you put it through the column still again, you get something that is very light with sort of subtle nuances of flavor, but the higher alcohol you distill to, the less flavor you carry with it. And so you'll get something that's much cleaner and lighter, without a ton of flavor. But there still is some. It doesn't taste like vodka. It still definitely tastes like a grain spirit, but it's very light. If you distill in a pot still, you get something that's very, I kind of think of it as very narrow and refined. You really kind of hone in and concentrate on certain sets of characteristics, and that's kind of your focus. So even if you think about Scotch single malts, which are done in pot stills, compared to a bourbon, even the kind of the placement of the flavor, like if I'm kind of to map it out, like Scotch is kind of often like this, and bourbon's just kind of like this. Like that to me is visually how I kind of represent the differences being column and pot stills. But yeah, the other thing in Canada we do is usually we wouldn't, the most of the whiskey we make wouldn't just be made in a pot still. It'd be made, first you'd go through a column still, and then your second distillation you'd use a pot still. So you're not distilling multiple times in a pot still, as in some countries like Scotland, you'd start in a column still and then a pot still. But I think the core kind of takeaway for me is, I've talked a lot in this series about the diversity of Canadian whiskey. So we're using kind of all the grains regularly that are common and at our disposal. We're in fermentation using multiple types of yeast and fermentation regimes, even within a single distillation facility. And then we're using multiple types of stills. So not even, just different shapes of pot stills, but actually we're using column stills and pot stills. together. And so what you get at the end of this is this spirit to go into barrels that's so diverse. And so you have a single distillery that's making a corn whiskey that's been distilled twice in a column still, a corn whiskey that's been distilled once in a column still. You have a rye whiskey that would be distilled once in a column still. You might have another rye whiskey that's distilled one in a column still and once in a pot still. So incredibly diverse, kind of the selection of tools at the arsenal for distillers. And what it leads to is a huge broad range of whiskeys coming out of a single distillery. And it makes it incredibly interesting and diverse. So that's a bit on distillation. So we'll talk about maturation in the next video.